Okay, so the new thing for today, it's called solving by graphing. Well, so you graph, and you graph the thing, and let's say it looks like this. It's really simple. The solution is not where the vertex is. I'm glad you know that that's an important point. Somebody brought that one up. That maybe that's the solution. That's not it. The solution is where it hits here and here. They're called the solutions, and they're so important they actually have 4 names. As you reach higher level math classes, they start out being called the solution. That's what we call them. Then they're given another name. Well, actually, I think you know one. 2 words. X. X. Nope, this isn't the X and the Y. Those are the X whats. X, say it louder. X-intercepts is correct. They're the X-intercepts and they're the solutions, and there's 2 more names for them. The roots and the zeros. There's 4 names. I want you to write all 4 down. So everybody right now, draw this picture of a parabola touching the x-axis, and then you need to write down the 4 names that I just said. And I know you might only remember 2, but you got to get all 4. And we'll get them by like having people, somebody will remember each one. Give me one of the ones I just said.
I don't remember parabola.
The name is not, this is a parabola, you're correct, but that's not the name for these special spots. I just said them. Nobody's got short-term memory? X, no, that's not the X and the Y. This is the Y, and that's not at all related. The X-intercepts, thank you. Somebody's got a short-term memory. Everybody write that down. The X-intercept, and we need an S because there's 2 of them. X-intercepts. I'm going to pause. Will you write that down? Correct. The second name for it, roots. They are the roots of this equation.
Are we going to be like writing down these words in our homework tonight?
This is your homework, right? This is part of your homework is learning this. So I'm helping you learn it right now. There's 4 names. X-intercepts, roots. What else? Zeros. Very good. Don't talk, please. That's the 3rd one. Zeros. And there's one last one, and it's the one I started with, actually. It starts with an S. Can anybody do it? Solution. The solution. Sounds like a really bad wrestler's name. The solution. You know, there's the Undertaker. There's the, I don't know, the Body. Jesse the Body.
Who's Jesse?
Ventura. Do you remember Jesse Ventura? He was actually the governor of the state of Minnesota. He was a wrestler back in the old days, and he was Jesse the Body Ventura. He ended up, actually ended up moving out of Minnesota, I believe. But he was the governor here for a while. Actually, I think he did for a while. I don't know for sure, but yeah, that's true. He's kind of a celebrity. So. All right. So those are 4 names. Now, why are these things important enough to have 4 different names? Because you do, as you get into high-level math, you do tons of parabolas, and then the answer to it, like, seems important, right? The answer to a parabola is what makes the parabola equal 0. So, like, for instance, let's say I had this 2x squared minus 5x plus 4, or some parabola, and you just ask, what's the solution? The solution is what makes it equal 0. Why would we want it to be 0? I've told you a whole bunch of things about these. One of them I said was that if the y was 0, you have the x-intercept. I'll say that differently. The x-intercept is where y is 0. See, if I put a 0 there, I want to figure out what number could make this whole equation equal 0. That's why we call it the zeros. So where are the answers? When you graph this thing, which you have already learned how to do, remember, you stick in numbers and you find points. You graph a bunch of points and poop, poop, poop. All of a sudden you find out, oh, it hit here and here. That's the solutions. Wherever it touches the x, that's the solutions. They're the zeros. They're the things that'll make the equation equal 0. All right, so you're graphing. You've already done this. You forgot this all figured out. You got a graph, and it's like this. Do, and you graphed a bunch of points. Do, and now you get the kid has got his parabola all done. That's done. And what was the most special spot? The vertex. But what's the answer? The solutions? The zeros? Then the roots? Those spots. So if this was at like -1 and this was at like -6, then the solutions, the roots, the zeros of this thing are -6 and -1. It's wherever it touches. Now, a smart question might be, but what, Mr. Server, what if it doesn't touch? Then it has no solutions. That means if you have an equation like that, then there is no way to make it equal 0. There is no x-intercepts. There is no solutions. There's no roots. And that means if I put a 0 here, I can't find any number to put in for those x's that would make it work. There's no solution. All right, so my question for you is this. Let's say I have graphed this by now. Have you learned enough to know where the solutions are? Yeah. It's there and there. Where it touches. No big deal. What if I drew it like this? What's the solution now? There's no solution. So either it touches twice, or it doesn't touch, or there's one more possibility. What if it touches but only once? Can you imagine a moment that you can make it just perfect so it only touched once right there? You can. And then there's only one solution. See, it only touches in that one spot right here. That is the solution, the root, the 0, the x-intercept. Okay, so it's all about where does it touch. So homework's going to look like this. You're going to have a picture. You're going to graph, just like you did before. It's just you're going to have to pick out of all the things you graph, what are the most important ones? That and that. That's it. It's called the roots, the zeros, the x-intercepts. All right. So now I'm going to give you a worksheet, and we're going to do a couple together. I'm going to pause while I do that. Okay, we got number 1. I got it written on the board here. Okay. So what I told you yesterday is I think the smartest way to do these is to make a skeleton for them. What on earth was I talking about? You make little parentheses. I like to think of these as like the rib bones or something of the little skeleton. And I'm going to do that. You do not have to do that. But if you get it wrong, it allows me the ability to taunt and laugh at you because you didn't do the right way. No, of course, I wouldn't do that. But if you use this little method of making a skeleton like this, and then you drop in, okay, focus, and you drop in the number, then you should be able to get your answer. All right, so start by sticking in -6. And I'm going to pause for a second while you figure out what each of those adds up to, and you put the right number right there. I'll pause. Let me give that a try. I'd say the most common mistake in this class that I see is people go 6 squared. Oh, 6 times 2 is 12. No, it's 36. Good. It does have a negative in it, but it's negative times negative when you square it. It's positive 36. Now this one is a negative 36 because that one's got only one negative. This has got 2 because it's -6 times -6. So this one's positive 36, this one's negative 36. And then it says plus 8 equals 0. And 8 equals 0. What?
No solution.
No, that's I get that you thought it was no solution, but this is actually kind of weird. They should have had a y right here in our equation, and I get what they were trying to do was just find the um, the solution, but we need to graph it first. So this really should be a y equals 8. So when you graph it, you'd put in -6 and you'd get 8. How many of you got an 8? Oh, a bunch of you did. Cool. Can you unplug, please? All right. So 8 was your first thing you would have gotten. Next, would you please put in the -5 and just get me started on that? I'm going to put it in my little skeleton thing. Not you. I called somebody else. I'm glad you know how to do it, but... Okay, so I'm going to put in -5 and -5, and how do I start? You get 25, that's correct. And then how about this part? Positive or negative? -30, and then +8. And then if you put it all together, together, do you get this makes -5? -5 plus 8. -5 plus 8. Can you tell if it's positive or -3? +3 is correct. All right. Now let's try making that little skeleton thing and putting in the -4. Putting in a -4 next. I'm making my little skeleton. And I'm putting in -4. Okay, CF in front row. Tell me how to start.
Square the -4.
Which makes?
12.
Nope.
-12.
Nope. 4 squared.
Sorry,
It's all right. It's all right. 16 is correct. And then this. 6 times -4. Okay, with the calculator over there.
What?
What? It's okay. It's legal. 6 times -4. -24. Plus 8. Then, again, calculators are legal in this class, so you could use a calculator to do this, but I bet we can do it without it. If you make the 16 and the 8, that adds up to 16 and 8 adds up to 24. 24 and -24 makes 0. Now, that is special. I want you to think about this for a second. That's the x-intercept because that's where y equaled 0. See? Y equaled 0. So that's the root. That's the 0. That's the x-intercept. All right. Let's do one more. Is it possible that there's 2? Remember how sometimes it touched twice? If I have a parabola, do you get sometimes it touches twice? So there's probably another x-intercept where y equals 0. So let's see if we can find it. If I put in -3 into my skeleton, I get 9. And then 6 times -18 plus 8. 9 and -18 makes -9. -9 plus 8, -1. Good. Well, that wasn't equal to 0. It's kind of disappointing. I kind of thought it would equal 0 again. But I should try another one. Just one last one, and I bet you this is it. I bet you when I put in -2, it'll work. My skeleton equation. Drop in -2. -2 squared. 4. -2 times 6. -12 plus 8. Oh, that was it. Know why it was it? Because was it equal? That's 12, and those two together make 12, plus the -12. There it is. There's the other one. Do you get? That's what's different about today is that we need to find those special spots. Those are the x-intercepts because y equals 0 there. When you actually graph it, this spot and this spot is where it's going to hit the x-axis. All right, so let's actually graph these points now. You do have a little graph for them, right? So graph the point negative 6, 8, negative 5, 3, negative 4, 0. All right, get those dots graphed. And while you start graphing those, I'll figure out these last two for you. Put in negative 1. I get 1 minus 6 plus 8. That'd be 9 minus 6, which would make 3. And then the last one, zeros are easy to put it because they just cancel off. All that gets canceled, and the answer is just 8. There we go. There is all the points. Now I'm going to pull up a graph, or a piece of graph paper, and we'll see if your graph looks right. Okay, so now we're going to graph this puppy. Negative 6, 8, goes over to negative 6 and then up to 8, and then the dot's right there. Now, of course, you don't draw those lines each time. I'm just trying to show you how I got there. Then I got negative 5, 3. Here's negative 5, and up 3, and there's my dot. And then I've got negative 4, 0. And then I've got negative 3, negative 1. And then I got negative 2, 0. And then I've got negative 1, 3. And last but not least, 0, 8. Look at that beautiful U parabola shape. But the new thing for the day, those are the solution. Those are the roots, the zeros. Those are what actually make the equation equal 0. Okay, so if all you do is graph them today, you're missing the point. When you're done graphing it, you have to pick which ones were the winners, so to speak. These guys are the winners. So I would say negative 2 and negative 4 are my roots. I'm just going to let you use the shortest word for it. It's a lot shorter to write root than x-intercept or solution. Roots are negative 2 and negative 4. So write that on number 1. If you haven't already got that, I know a lot of you graphed it, but actually write roots are negative 2 and negative 4. That's the actual answer. The picture is just part of it. All right. That's all I have for the video for today.